Unit 6, Lesson 5, Modeling with Sinusoidal Graphs. So in the last lesson, we learned how to come up with the equation if we're given a graph. We also discovered that it's possible to come up with an equation in terms of sine and an equation in terms of cosine. It doesn't matter which one you use. Here is kind of a list of tips for when you're deciding if you should develop an equation using sine or cosine. Okay, so the first tip is if the graph starts at its maximum, it's best to choose the cosine function when you're coming up with an equation, right? Because if you have a graph that starts here, that's really easy to identify the cosine function. It's easy to find the maximum. It's easy to see that there's no shift, etc. Okay. Likewise, if there's a graph that starts at its minimum value, so like this, okay, it's best to model this using the cosine function. The only thing you have to do is make sure a value is negative because it's reflected. If you're given a graph like this one, where the graph starts at the axis of the curve, it's best to use the sine function when coming up with the equation. Okay, so just keep in mind that if you're asked to come up with the equation of a graph, it's totally fine to develop the equation in terms of sine or cosine. It's just sometimes it makes the most sense to pick either sine or cosine. And those points will help you decide. Okay, example 1. The following graph represents the height of a nail that is stuck in the wheel of a bike. Determine the equation of the graph. Okay, so just to give you some background, right, if you were picturing a wheel of a bike, okay, it's riding along the road, okay, it's going to hit the nail. So the nail is going to start at the bottom of the wheel. And as you keep biking, the wheel is going to go around and around. The nail is going to travel to the top of the wheel, and then it's going to rotate back down. And it's going to continue a cycle like that. So that's why we can use a sinusoidal function to model this scenario. Okay, so we have the graph pictured there. Let's go ahead and determine the equation of the graph. Okay, so we can use the tips above to figure out if we should pick sine or cosine to model this equation. Okay, and because this graph starts at its maximum right at the y-axis, I'm going to go ahead and pick cosine. Okay, so now we just go ahead and use all of our key features from the graph to develop our equation. So first, let's start with the equation of the axis. So you're going to take the maximum value, which is 3, add it to the minimum value, which is -1, and divide by 2. So we're going to get an equation of the axis at y equals 1. Okay, and that's helpful to us because we know that the equation of the axis from the graph is the same as the q value in the equation that we're trying to develop. Okay, secondly, let's find the amplitude of the graph. So it's going to be the distance between either the maximum or the minimum point and that axis of the curve, and that axis. So the maximum's at 3, and the axis is at 1, so that means the amplitude must be 2, because that's the difference between them. Okay, and then it's good to find the amplitude of the graph because it's the same as the absolute value of the a value in the equation. Okay, and we know that our a value in our equation is going to be positive because our cycle of cosine that we're studying has not been reflected. Okay, it's still right side up. Okay, let's look at the period. So one cycle is highlighted here. So let's look at the difference of the x values. Okay, so it starts at 0, finishes at 10, so that means one cycle is 10 seconds. So the period is 10 seconds. Okay, and the period from the graph is related to the k value in the equation. So therefore, if we know the period, we can find the k value. It's 360 divided by the period. So our k value is 36. And finally, we need to ask ourselves, is there a phase shift? Okay, and since we're using the cosine function, there is not a phase shift because the maximum is right on the y-axis. All right, so now we have all the values of our key points. Let's build our equation. So we're dealing with the height in terms of time, So it's equal to, so our A value is 2, our K value is 36, there is no phase shift, and our Q value is 1. So there's your equation. Okay, example 2. A sinusoidal function has an amplitude of 2, a period of 180, and a maximum at 0 and 3. Develop an equation for this scenario. Okay, and it wants you to come up with an equation in terms of cosine and sine. Okay, so I'd like you guys to pause the video and try this one on your own. My clue for you is start by finding those key points. See if you can figure out the axis. See if you can figure out the amplitude and the period. Okay, once you have those 3 values from the graph, you can come up with the Q, A, and K values. Okay, so pause the video and then unpause when you're ready to check your answer. Okay, so to find the axis, you would have used these 2 things. You would have used the fact that you have a maximum at 0 and 3, and the amplitude is 2. Okay, so the axis is going to be 2 units below the maximum, which is 1. Okay, the amplitude was given to you in the question. It was 2, so that was pretty straightforward. Same with the period. Okay, and then those 2 allowed you to calculate the A value and the K value. So if you wanted to add more to your graph, okay, so because you started at a maximum, you know that we're going to be using the cosine function. And then you know that your full cycle is going to end at 180. So you're going to have another point at 180 and 3. Okay. If your amplitude is 2, then you know that your minimum is going to occur halfway through the cycle, so at 90, and it's going to occur at 2 units below the axis, so at -1. Okay, and then because of the symmetry that's involved with drawing a cosine function, you would know that your other 2 points happen here. And that would be a full cycle of this graph. So now you should be able to come up with your equation, right? It wasn't actually mandatory for you to draw this out. I just thought I'd show you. So your equation is going to be, so 2 cos, our K value is 2, there is no phase shift, and our Q value is 1. Okay, so hopefully that's what you got. Now, in order to write this in terms of sine, everything's going to be the same except for the phase shift. So let's figure out what the phase shift is very quickly. Okay, so if we extend this, we know that there's going to be another point there. So 1 cycle of sine is going to be like that. So there's a phase shift to the left, 45 degrees. So when coming up with the equation, everything's the same except now there's a phase shift involved. Example 3, Luke is swinging back and forth on a swing that has been attached to a bar between 2 huge trees. His distance from the trees in terms of time can be modeled by a sinusoidal function. At 2 seconds, he is at the maximum distance of 8 meters from the trees. At 6 seconds, Luke is at a minimum distance of 3 meters from the trees. Determine an equation of a sinusoidal function that describes Luke's distance from the trees in relation to time. So we're given 2 points. We're told that the maximum point is at 2 and 8, and we're told that the minimum point is at 6 and 3. Okay? So with those 2 points, we can actually find everything that we need to come up with the equation. So because we're given a maximum as our starting point, let's use the cosine function to develop an equation. Okay, so let's start finding our key points. So the equation of the axis is going to be the maximum plus the minimum divided by 2. So it's going to be 8 plus 3 divided by 2. Okay, so we know that the axis from the graph is the same as the Q value in the equation. Now we know that the amplitude is going to be the difference between the maximum point and the axis of the curve. Okay, so we're going to get an amplitude of 2.5, which then means that our absolute value of our A value is equal to 2.5. Okay, let's find the period. So we know our maximum and minimum value, and we know that half of the cycle happens between that maximum and minimum value. So to find the period, we just need to find the difference between the x values of that maximum and minimum point and then multiply it by 2. So the maximum starts at 2 on the x-axis, minimum at 6. So the difference between 2 and 6 is 4. So we know half of our period is 4 seconds. So let's multiply it by 2 to get our full period. So our period here is 8. Now with that, we can calculate our k value of the equation. Okay, and finally, let's calculate the phase shift. So we know that the cosine function starts at its maximum. So here is the start of one cycle of cosine. So that has indeed been shifted, right? It's been shifted to the right 2 seconds. So our phase shift is to the right 2. So when we put that in our equation, we're going to put it in as -2. Okay, so our equation is going to be in terms of height and time, which is in seconds. So our A value is 2.5. We're using cosine. Our k value is 45. We have a phase shift to the right 2. And we have a q value of 5.5. If we were using the sine function, it would be the same except our phase shift might change. Okay, so as you can see, if we extend that graph and turn it into one wave of the sine function, you're going to see that there is no phase shift. The start of the sine function happens right at that y-axis, so there's no phase shift. So the equation in terms of sine is just a little bit simpler. Example 4. Emily is riding her bike and she gets a small nail in her tire. Her bike tire has a radius of 35 centimeters. Determine the equation of the sinusoidal function that describes the height of the nail in the tire in terms of the distance that the wheel travels. So I've set up my axis. Okay, so we're comparing the height of the nail above the ground, and we're comparing that to the circumference, or the position on the circle where the nail is. Here's what I mean by that. So we know that the radius of the circle is 35 centimeters. Okay? We know that the first time that the nail enters the wheel is going to be at the ground. This is the point at which the nail starts. Okay? Then the nail is going to travel around in this pattern. Okay? So in terms of what position on that circle the nail is at, so to determine where in the wheel the nail is, we can compare its position to the circumference. Okay? So one full circle or one full rotation would be the period. Okay? So the period here is equal to the circumference, because one time around that circle is the period, and one time around that circle is also the circumference. So if we want to find the period first, we know to find the period, we just have to figure out the circumference, because one full circle, or the circumference, is equal to the period. So the period is equal to the circumference, which is pi times diameter. Okay? And the diameter of the wheel is going to be double the radius, so it's going to be 70 centimeters. So if one full rotation is 70 pi, that means half of a rotation is 35 pi. So we can add that to our diagram. And we know that this point here is 0 or a full rotation. Okay? So remember, the goal here is to come up with the equation, okay? And we found the period, so from that we can find the k value, so let's go ahead and do that. Okay, now if we reduce this fraction, we get down to 36 over 7 pi. Okay, we divide both by 10. So we know our k value. But now to find the equation of the axis, which will help us to find the q value, and in order to find the amplitude, which will help us to find the a value, we need to start graphing this scenario. So let's go ahead and do that. So let's label our x-axis. So we know that one full cycle is going to end at 70 pi. That's the circumference. Okay? And we know that the height of the nail at the very beginning of the cycle is going to be 0 because the nail starts on the ground. And then after one full rotation, it's going to end on the ground as well. Okay? So it's going to reach its maximum height halfway through the period at 35 pi. How did I know that? Well, let's look at the picture of the circle, right? Halfway through the rotation is where the nail is at the highest point above the ground. And that highest point above the ground, right, this entire distance here is at 70 centimeters. So that means our maximum is at 70 centimeters and it happens at 35 pi. Okay. So now that we have a kind of a better picture of what our graph looks like, we can draw the outline of our graph and start to come up with the other key points. So the other key points we have to find are the equation of the axis, right? That's the maximum value plus the minimum value divided by 2. So the axis is at 35, which is going to be right here. Okay, now the axis is the same as the q value in the equation. The next thing we need to find is the amplitude. So the amplitude is the distance between the maximum or the minimum point and the axis. So the maximum point is 70, the axis is at 35, so that means our amplitude is 35. And that translates into the absolute value of our a value is 35. Okay, and we know that a value is going to be negative in our equation because if you look at our graph, one cycle is one cycle of the cosine function, but it's flipped. So there is a reflection on the x-axis. So there is a reflection. Okay, the last thing we need to see is there a phase shift? And no, there is not. So we learned at the very start of this lesson that if the minimum of the graph starts at the y-axis, which we have here, then we use our cosine function with a negative a value, and there's no phase shift. Okay, that makes sense. So our equation is going to be, so our a value is negative 35. Our k value is 36 over 7 pi. We do not have a phase shift, and our q value is 1. Okay, there's just a mistake I saw. Okay, the q value is actually 35. Alright, so there's your final answer. Part B. If Emily rides a bit longer, and the bicycle tire completes 20 revolutions before she stops, determine the domain and range. Okay, so this is what you need to picture here. So if one rotation of the wheel is equal to one cycle of the cosine function, then that's going to be just repeated 20 times. Okay? So, in order to find the domain, we need to compare the period of one cycle. So we found the period of one cycle was equal to 70 pi. So, if we're repeating that cycle 20 times, we just need to do 20 times the period in order to get our domain. So 20 times 70 pi is equal to 1,400 pi. So that means our domain is x is an element of the reals such that x is greater or equal to 0 but less than or equal to 1,400 pi. Okay, for our range does not change, okay? The range of one cycle is going to be the same as the range for 20 cycles. So the range is y is an element of the real numbers such that y is greater than 0 but less than or equal to 70. Okay, I just got those values from this graph. Okay, finally, what is the height of the nail above the ground when the wheel has traveled 150 centimeters from the time the tire was punctured? Let's just use our equation and plug in 150. Okay, now let's do the math. So therefore, the nail is 49.49 centimeters off the ground when the wheel has traveled 150 centimeters.